Let's talk about self-contained components. And as we say, the more contained, the better, the merrier. And every good thing should start with an ad and end with an ad. So I work for a company called SkyShoot. At SkyShoot, we improve experiences that people have with property, whether you're buying property or renting or living in a property. And of course, we're improving these experiences with technology. And at the heart of our company, our greatest asset are brave engineers passionate about property. So if it sounds like you, join our cause. Also, we make cool T-shirts, and somewhere randomly in this presentation, there will be a discount code. So look carefully. Okay, let's start. So a little bit of business context, because of course the approach that I'm going to talk about is only relevant within our company, or maybe a company that has similar business goals or similar business values as we have. And so not necessarily applicable universally. First of all, we all full stack engineers. We don't have like people specializing in front end or people specializing in back end. Every engineer should be able to deliver a feature end to end. We very much focused on front end because users don't interact with your backend. They actually work with your front end. They don't care what your backend looks like, what your database looks like. All they care is the button is in the right spot and they can click it. So we're very much focused on the front end. All our energy is because this is where we bring the value, and this is what brings us the money in the end, the front end, not the back end. So we're kind of full stack, but focused on front end. And calendar time for us is the most expensive, in a sense that if we can make something quicker in calendar time, like spending less calendar days by putting more money or more people into it, we do it, or like paying more for infrastructure, whatever it takes, because calendar time is the only thing we can't give back to our customers, to ourselves, to the members of our team. That's why whenever we see an opportunity to compress that calendar time, we seize it and we use it. All right, so as Alexei already talked a little bit about the components and services, traditionally, this is the structure. You have some REST API, and you have some endpoints there. You have some endpoints related. Let's say you're building a task management system like Jira, and you have some endpoints related to users, some endpoints related to tasks and to comments. And typically what you would do, you would just mirror that same structure in your services. So you create a service for each business entity, and that service will be just a collection of methods that wrap the REST API. And maybe, of course, you might want to have some types there. So maybe you have typed the requests and responses correctly. So you have type safety all around. Whenever something changes in REST API, you come to the service, you update the typings. Make sure you always align your models with the API. So that works well. And components typically interact with the service. So if two components need tasks, for example, one component will be a list of tasks, and another component will be just a task page, just a page of one particular single task. They will just use the service. They will call the methods in the service, and then the service will then go to REST API, fetch the data, update the data, and then give it back to components. Then that totally makes sense for the REST API, because REST API is set in stone. It doesn't change quite often. It actually precedes your application. Most often when you start building your front end, REST API will either be there already, or you will have some kind of mock API that has already some structure. So you're already driven by that backend. But interestingly, when we start using, and when it comes to the state as well, what you would have is, in your task service, you will keep the data state in the most simplistic scenario. And in the components, you would keep like what I call a UI state, which is basically means pure UI state. Like, for example, you have a menu, and whether the menu, like a set panel, is it shown or not shown, that's a pure UI state. That's something that you don't typically store on a server. but everything that's related to the data that you store on the server, that typically goes and lives within the service. Could be an observable. Of course, if you have a more advanced application, you might use some NGRX, NGXS to manage the state. But in a more simplistic scenario, your data state would live and be updated somewhere in the service as well, and be provided, of course, to the components so they can reflect that data in the UI. But then when you change to GraphQL, where in GraphQL, your API doesn't change that often, but you as a user of that API, you can actually control what fields you want. You can actually build your own requests on the front end. It's very flexible, so you can design pretty much the request that's tailored specifically to your component. And in that sense, what we found, if we just continue to follow the same methodology, we found that if we just put like a GraphQL queries inside the services, that just becomes a waste of time for you to, for example, you have a component displays 3 properties, and then you want another property to be displayed there. You add it to the service first, and then it comes down to your component. You add it to component, and you constantly find yourself switching between component class and service class, and that's tedious. And also you have extra file that just occupies space. So that's primarily for us, the problem was that it's a waste of time of engineers, which is the most expensive thing. Another thing that we have is we have code generation. So remember I talked about trying to mirror your models from the API to your models in the front end. That's actually automated with GraphQL. You can automatically generate a response model and the request model with just based on your GraphQL API and the GraphQL query that you use. If you haven't used GraphQL API, it probably doesn't sound like much to you. So, but we unfortunately don't have time today to explain what GraphQL is. But if you're serious about your career, you should already know what GraphQL is. Anyway, so we decided to just get rid of all this stuff and just have this simple interaction where the component itself, and this is where the self-contained feature kind of comes from, is that the component itself already contains the GraphQL query itself, and it actually goes directly to the API and fetches the data. Of course, we're using like a library underneath that, but essentially in your component itself, you define what data you fetch, what mutation you run, and even more interesting, because your GraphQL is real-time, majority of GraphQL APIs are now real-time, it means that you can actually subscribe to the data changes directly on the server. And so your component, so today it's very easy to build components that they just display the data in real time, like be it like currency exchange chart or some kind of a messaging system. You can very quickly build that component that just displays the data on the server. And because of that, actually what you could do, you could put the data state, you can put your state on the server itself. You actually no longer need any sort of intermediaries to hold your state. And what it comes down to, your component just sends a request to the server, please update that field, please update my name, for example. And then it just listens for updates from the server. And whenever the field, the name has been updated on the server, whenever the data change has been committed to the database, we will receive the update from the server right away, and we can display the new value right away in our application. And that streamlines and simplifies the designs of our applications. And as a result, we can spend more time on actually building great UI and not on managing state so much. Of course, there's always UI state that you have to manage. There's a pure UI state, and also some kind of interaction between your components that you need to take care of in the complex scenarios. But generally, this is current approach, and that saves a lot of time. Yeah, so just to recap how these self-contained components look like, I think they're kind of similar to container components. What I see is there's a natural evolution of the container components or smart components in a GraphQL world. or in a world where you have very good control over your queries on the front end, and you have this real-time capability. So they receive very minimum inputs from parent. Like, for example, if we are the component that displays a product, we wouldn't get product title, product description, product price. We just get the product ID, and that component will be responsible for fetching that data from the server, making sure that data is up to date. So they define the GraphQL subscription and mutations inside the component class code itself. They rely on data models derived from GraphQL schema. So we use GraphQL CodeGen to assist with that. It basically means that every time you change your request, a return type is automatically generated for you. You don't have to do it by hand anymore. Which is, again, great time saver. So we're all about creating these great development experiences in the end. And of course, we use RX to observe the state from the cloud. I'm sure you're all familiar with that. And we mutate directly in the cloud. So if someone updates something in our component as a part of that component, let's say put something in a cart, our application itself just sends a mutation to the server, says, well, now that product is in the cart, and then the update comes back from the server, and then we now see that product in the cart. And it's single responsibility, of course, responsive, and the responsiveness code is always there. Single responsibility in a way that's like a small feature, like a product or a card could be an example of that. And now we come to the example, which is about products and carts. So we built this system where you can buy some products. We don't dwell too much about what these products are, but the important thing is you have a cart, you have a product that has a price, you can put them in the cart, and whenever something is added to the cart, the total is updating, and of course the list of items updates as well. If we look closer to the component, the self-contained component for the product, the inputs it receives is a product ID and the order ID that we are currently within, kind of like a cart ID. And as you can see, the component displays some description, title, price, some image, and also has some button. And this is how the GraphQL query or GraphQL subscription in that case would look like when we want to fetch the information for that particular product from the GraphQL API. So we'll fetch image, price, and that will go to the respective sections of the product. This way, we also need order because we want to know which order to add it to. Product has multiple states. So you can add and remove things from the cart. And if it's already in the cart, it should look like checkbox. If it's not in the cart, it should look like something we can add. Of course, we can update quantity on some products that support it. And some products can be not available based on if you already put some similar product to the cart, then another one would not be available. So sometimes it's either or. And for that, the product itself needs to be aware of what's in the cart and needs to be aware, should it allow itself to be added. So product component in this way contains the whole business logic that relates to that product and how it should behave within that component. So it's very easy. You just have one file where you update all this stuff. And if something you need to change about the product, you know exactly where to go. It's on one layer. And that's how it works together with the state. So we have a state in the cloud. Whenever we click the button, it fires the GraphQL mutation. The state is updated in the server, and the total in the card is a subscription on GraphQL. And whenever something is added, the total will update as well. And same happens with that checkbox. Whenever we add something, we wait for it to become available in the state on the cloud, and then only after that we put that checkbox in. Similarly, with the list of things that are currently in the cart, there are a lot of subscriptions that we handle at any given moment. Whenever someone wants to delete or add things to the cart or change the quantity of them, that is automatically instantly reflected in the component. And then because we're using state in the cloud, there is no situation where our data isn't consistent. So we have a 100% guarantee that what you see in the UI is exactly the same that you have in the database. It's always aligned, which is quite important, especially when you're buying something. And maybe I'll do a short demo of that. So this is the product. Just log in quickly. Hopefully I'm sharing the right screen, and hopefully it will work. Okay, so let's see. Okay, so this is the same thing that I just shown in the slides. As you can see, I have a list of products, and I have something already in my cart, the campaign. And if I add something to the cart, it will update the total and will update the list of the things. And these two components, the cart and the product, they're not connected in the application. They're not connected in any way. So we can take that cart and put it somewhere else in a hierarchy. It doesn't really matter. There's no service in between them. Between them is just a state that's in the server. That's how they communicate. And yeah, of course, it's all real time. That's how it basically works. And what's next? So just to summarize, why would you like to use them? Features are better isolated, so you have less merge conflicts, and there's less switching between the files. So it means efficiency. Just to quickly illustrate how it looks like in the code, this is an example of one such components. Here we have a GraphQL query where we specify, so this is a component that displays a top menu. It also needs to display user details in the top right, the name of the currently logged in user. This is the query in GraphQL that we use to fetch the user by ID. These are the things that we fetch. And in this method, in this component, this is how we fetch that. This is the type that is generated for us. It has the reflection of the shape of the return based on the query. So that's generated automatically. Whenever we change something in here, in this query, that type will change accordingly. And this is the type of the variables that we need to provide as an input, which is quite important, because if we forget to do that, it will remind us that we should provide the variable of certain type. And as a result, then we can pipe it to get the actual user and display it then in the component. We just use, where's that? Somewhere. Yeah, so this is basically where we display that. Yeah, so that's how it looks like. So yeah, so it's, and whenever we want to change something, we just quickly add something to the query and quickly add this to the template. So we all stay within the same context. We don't have to switch contexts. And it's much easier for our brains to do that. So efficiency. Some things that maybe why you consider them not such a great idea for you in your case, not really reusable in another application, primarily because we have GraphQL query in the component. So it will only work in another application if you actually have exactly the same GraphQL API in another application, which is likely in our case, but not likely in most of your cases, I think. But one major point, it actually takes a while to convince your team that you don't need to create these services just as a collection of queries. You don't need to create these extra layers. It takes considerable time to convince your team that's a good approach, because Angular developers, I think, they're very good at following the Angular way. And these self-contained components, they kind of go a bit outside of the Angular way. And that, I guess, creates some conflict internally. So something to consider. And yes, so we sell T-shirts that are designed by engineers, and T-shirts designed for engineers. They're quite funny. They're made of good materials, earth-friendly, and very good ink and whatnot. And 50% of the proceeds go to support tech communities and bootcamps in here. And yeah, so if you go there, you can use that code, Anglo Sydney, and that gives you 40% off. Only works today, though. So if you want to buy something, it's better be today. Yeah, so on that note, you can post your questions in the comments. And over to you, Alexei.